Okay, to quickly run through this question, simplifying the fraction that you see, what you can do, it's like reversing the act of adding two fractions together, is split your two terms at the top into two fractions with the same denominator. If you do this, the first fraction simplifies quite quickly to being a half, but the second one's a bit more difficult and you have to use indices instead of surds really to do this. So that first value x that you can see in the form that you're given, x is going to be a half, but finding out what y is a bit more difficult. Because you lose the square root of a at some point here, so we get a to the power 1 over a to the power 1 half. And then you can use the subtraction rule for indices. Notice how I've taken 1 over 10 out. It's like the multiplying fractions rule in reverse. I've taken the 1/10 out, and we're doing 1 minus a half, which is a half. And that is the square root of a again. So we've actually done the whole question using this idea without really having to resort to multiplying the top and the bottom by the square root of a. So that's the answer. I do want to take you through the alternative method, which is timesing the top and bottom by the square root of a. It is called rationalizing the denominator. There's a reason we do it, and it just makes things a lot simpler. We like to have denominators as simple as possible. So if we times the top and bottom by root a, we have to expand the bracket at the top. And root a times root a make a, so we just get 5a when we expand the bracket, and then a times root a as the second term, and on the bottom it's 10a. Now when we break up into two fractions, just like we did in the previous screen, we already have the square root of a at the top of the fraction, which makes things a lot easier. The first fraction, we can cancel the a's, and then the factors of 5 as well, to get us a half. We can just cancel the a's in the second fraction, and we're done straight away. 1/10 of the square root of a, and that's a little bit easier. Okay, so super happy face, and I don't really see the likeness if I'm honest, but I'll put it there anyway.